Welcome to this video. In today's video, we would like to write a program that sums all the items in a list. So here is my list. The name of my list is numbers. It has 5 elements, 10, 20, 30, 40, and 50. Here we would like to calculate the sum using the sum of all the items in our list using the sum function. In order to do that, I define a new variable called total. Then it is assigned to be the sum of the list called numbers. So basically, I'm using the sum function to calculate the sum of all the items in the numbers list. And when I run this code in the output, when we print the total, it's 150. So this is one way to do it. Another way to do it would have been to write a for loop, for example. And using a for loop, we could do that. For example, I'm having a variable called total1 equals 0. And we could say for num in numbers, we could have total1 plus equals num. And then we were printing the value of total1. So when I run the code, we see that the output is the same. So there are two ways to do that. The first one is to simply use the sum function. So this sum function is going to add 10 plus 20 plus 30 plus 40 and plus 50 and assign the output to variable called total. And we print the total in the output here. Or another way to do that is to use a for loop. For example, here, in order to use a for loop, we need to initialize a variable to 0. Then we are having for each num is my iterating variable here. For each num that is in numbers, we are going to add that element to our total1 variable. For example, in the first iteration, num equals 10 because the first element in numbers is 10. Then we are going to have total1 equals total1 plus num. And this means that total1 is initialized to be 0, so it's 0 plus num is 10, so the total1 equals 10. Okay, so this is the first iteration. In the second iteration, num equals 20 because the second element of numbers list is 20 and we are iterating over each element of this. So it is 20 and we are having total1 equals total1 plus num. And we know that from previous iteration we calculated total1. Total1 is 10. So we are having 10 plus 20. Why 20? So 20 is the num in this iteration and 10 is the previously calculated total1. So 10 plus 20, it will be total1 equals 30. Then we have num equals 30 in the next iteration. And this means that total1 equals total1 plus num, meaning that we are going to have 30 plus 30 and we are going to have total1 equals 60 this time. Why 30 plus 30? Because total1 is 30 from the previous iteration and num is 30 also. So we are having it equals 60. Then we are having num equals 40, meaning that total1 equals total1 plus num, and we are going to have 60 plus 40, so it is 100. Then we are going to have the next iteration, which is 50, num equals 50, so total1 equals 100 plus 50, which is 150 in the end. So we see that we are having 150 in the end. So in order to address this problem, there are two methods here that we explained. There may be many methods to address a problem. It depends on you. So the easiest way, I think, is to use the sum function, and simply it is going to do everything itself. And we are assigning it to total, and total is being printed. But otherwise, you can also have a for loop, which is not so hard to be done. For each num that is inside the numbers list, we are adding num to the total one variable, which is initialized to 0, and then we are printing it out. And we could test it on many different lists. For example, I could have a list, numbers 1, for example. I could have 10, 50, 100, 150, 200. Then here I could have my new total equals sum. What was the name of the list? Yeah, numbers 1. Okay, so we're going to use that. And then we are going to print this message saying that the sum of the second list is, then we are having my new total. So when I run the code, this time we see that the sum of the elements that are inside this list is 510. So this is how we can use the sum function. We could get the same result using a for loop as well. So if I wanted to do a for loop, I could say total 2 equals 0. First, this is my variable. Then we are going to have this code, meaning that we are having my iterating variable num iterating over the numbers 1 list. Then in each iteration, we are adding the value of that element to total 2, and we are printing it out. So we see that using a for loop, we can also do that. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to multiply all the items in a list. So here is my list. It has 4 elements, 2, 3, 4, and 5. We would like to know what would be the output of this. 2 multiplied by 3 multiplied by 4 multiplied by 5. What is the output of this? Of course, we can do it ourselves manually, but how can we do it using Python? Here, first of all, we are going to initialize a variable to store the product. So it is called product and it is initialized to 1. We are having the loop that we need to iterate over all the elements of this list. And in each iteration, we are going to multiply that element by the product, okay, which was initialized to be 1. So what we mean here is the following. So in the first iteration, we are going to have num equals 2. So product equals product multiplied by num, meaning that we're going to have 1 multiplied by 2, meaning that product equals 2. Okay, so this is what we're going to get. Why? Because this product multiplied equal num is exactly this formula. So it depends on us. If this is easier for you to follow up, you can simply write this instead of that. They are the same thing. So here I'm having the product equals product multiplied by num. So product is 1 because it is initialized to 1. Then num is 2 because it's the first iteration and the first element in the list called numbers. It's 2, so the product equals 2. Then in the second iteration, we are having num equals 3, meaning that product equals 2 multiplied by 3, which is 6. So why 2 multiplied by 3? Because the formula says product multiplied by num. So product is 2 and num is 3. In the second iteration, num is 3 because it's the second element of the numbers list. So the output of the product is 6 after this iteration. Then we are having the third iteration, and here we are having num equals 6. So product equals 6 multiplied by 6. So we are having 36 as the output here. Why? Because the first number is the product from the last iteration, and the second 6 is the third iteration, which is our value. Sorry, this is number 4. So this place should be 4, and 6 multiplied by 4, it's 24. So here, 6 is the last value that we have for the product in the last iteration. So the value for the product variable is 6. We calculated in the previous iteration. So product equals product multiplied by num. So 6 comes from the last iteration of product multiplied by 4. So 4 is my variable num, and it is because it's the third element and we are in the third iteration. And finally, we are having the fourth iteration equals num equals 5, because 5 is the fourth element of the numbers list. And here we are going to have product equals 24 multiplied by 5. And the output of this will be 120. So when we run the code, we see that here, when we calculate this over the iteration, we are assigning everything to product. After the for loop is finished, we have done all the iterations. So we are having the value of updated product, which we expect to have 120 when we calculate it manually. And we see that here, when we are having the product of all items in the list and we're printing product here, it's number 120, exactly what we expected here. And if we have another list, for example, numbers 2, it's like having 1, 5, 10, 20, and we are having a list like this. We are going to have for num in numbers 2, and we are going to have product. For example, let me initialize another variable, product 1 equals 1. So product 1 multiplied equal to num. Okay, and in the end, I'm going to print this value. So the product of the second list is, we're going to have its print, which is product 1. So now I defined a new list called numbers 2. I have a new variable to store the product, which is called product 1. It is initialized to 1. I'm having a for loop over the elements of numbers 2, which is my list. So for each num in the numbers 2, we are going to multiply that element by the product 1 variable. And the output will be stored in product 1, and we are going to show it here. So we see that the output is 1000. And if we do the calculation, we will see that it's correct. Actually, 20 multiplied, So 20 multiplied by 10, the output is 200, and it is multiplied by 5, the output is 1000. So we see that the output is correct. So this is basically how we can have a program in Python to multiply all the items in a list for us. We need to have one variable to be initialized to 1 and a for loop. And in each iteration, we are going to have each element being multiplied by this product. And this product in the end is going to have the multiplication of all the elements in our list. Thank you for watching. Welcome back. In today's video, we would like to write a program that finds the second largest number in a list. So here is my list. It is called numbers, and it has certain elements, like 7 elements are there. So we see that one element is 10, 25, 36, 45, 36 again, 25, and 50. So 50 is the largest number, and 35 is the second largest number. So how can I find the second largest number here? in order to do that, I defined a function called second largest. Here, after declaring my list, I'm calling this second largest function and using the argument of my list. So this list called numbers is passed to this function second largest as argument. So in this function, we are having the first line when it is called, the numbers is converted to a set and then again converted to a list. But why do we need to do that? So if you see here, we are having number 36 two times and we are having number 25 two times. So we are having duplicates. In order to find the unique list, it is good to remove the duplicates. So here we are talking about the second largest number. When we are having duplicates here, it can provide some problems for us. For example, here is my numbers 2, and just assume that we sorted our list here in descending order, and we are having, for example, 50, 50, 46, 26, and 2. These are the elements of my list called numbers 2. Okay, but there is a problem here. So now if I'm looking to find the second largest number when the list is sorted in the descending order, the second largest number is the second element. Okay, so the largest number is the first element because it is sorted in descending order. You see, so the second element should be the second largest number if we have no duplicates. But because we are having duplicates here, we see that the second largest number, which is 46, is in the third place because we are having a duplicate here. So it's important to remove duplicates in order to avoid any mistakes or problems. This is why we need to first remove the duplicates. So if I remove the duplicates, we see that now the second largest number is the second element. And lists can have duplicates, but one of the features of the sets were the fact that they can only have unique elements. No duplicates are allowed in sets. Therefore, we are converting numbers to sets to remove the duplicates. But because we were working with the list and we would like to continue with working with the list, we are then again converting it to a list. So now if I print these unique numbers, you will see that in this new list, we don't have the duplicates that we are having in the numbers. So when I run the code, you see that 36, 10, 45, 50, and 25. So 25 is only one time repeated there, and also 36, it's only one time is being there. That's it. So you see that here also we removed the duplicates. After removing the duplicates, this is how my list looks like. Now I need to sort this list in descending order in order to find the second largest number. In order to sort it in descending order, we write down the name of our list, then we use the sort function. In parentheses, we are having reverse equals true. So this is going to help us to sort our list in descending order. And if I print my list one more time here, we see that now this unique numbers list is sorted in descending order. So this was the initial print of my new list with no duplicates. Then it is the version that we are having in descending order. Okay, so in descending order, we are having my list 50, 45, 36, 25, and 10. This is the sorted in descending order. Now we see that the second element is the second largest number in this list. And in order to access that, we are going to simply write down the name of the list and then the index 1, which is representing the second element. Why? Because index 0 is for first element and index 1 is for second element. Okay, so this is how it works. Index 1 is for second element and my second element is 45, which is exactly the second largest number in my list. So basically in this video we learned that we can find the second largest number in a list. And if I'm looking for the third largest number in my list, we can simply write down the index 2, which is representing the element 3, which will be 36. So we see that the second largest number is 36 and the third element here is also 36. Thank you for watching. Welcome back. In today's video, we would like to write a program that removes all occurrences of a specific element from a list. For example, if you look at here, you will see that I'm having a list here. It is called numbers. So the list called numbers has these elements. You see, 1, 2, 3, 4, 2, 5, 2, 6. And I'm having one specific element that I would like to remove it from this list. And that specific element is 2. So I want to have a new list in which we do not have this number 2 as the elements. So I would like to have a new list which contains 1, 3, 4, 5, 6. Okay. So in order to do that, there are many ways that we can do it. We can write down a for loop to have a new list being created, and if while we are iterating through the list, if the element equals 2, for example, we continue and we skip. So we're not going to insert that into our new list, and that way we can have our list being created. But another way is to use set comprehension. For example, here we are having the call of remove occurrences function, and we are having two arguments, numbers and 2, and it is assigned to an updated list, which is later on printed. So the output of this function is going to be assigned to updated list. So remove occurrences function, when it is called, two arguments we are having here. One is the numbers, which is my list name, then the element that we want to remove it. So this is my target element, number 2. So in this function, we are having two arguments, my list and the target. Here, this function is going to return for each item that is in my list. If that item is not equal to my target, which is number 2, we assign it to my new list here. So this is a set comprehension. So we are having the creation of a new list, and for each item that is in my list, which is the numbers, if that item, the iterating variable, is not equal to the target, which is number 2, then assign it to my new list. So this way, for example, item in the first iteration is actually 1. So 1 is not equal to 2 because target is the second element and second element is 2, second argument, let's say, or parameter. So 1 is not equal to target. Yes, it's true. So assign it to my new list. So my new list, let's say, new list equals 1 now. Then in the next iteration, item is 2 because it's the second element. So in the second iteration, we are having the second element. So 2 equals target is 2. So it is not equal to target. This is what it is asking. 2 is not equal to 2. So it is basically saying item is not equal to target. And we know that in this case, the item is 2 here, the item is 2 because we are in the second iteration. So the item now is 2, but we see that the target is always 2 because we didn't change it. So target equals 2. And we are checking to see if 2 is not equal to 2. And so this is false. 2 equals to 2. Therefore, we are not going to assign it to our new list. So our new list remains the same. Okay, so we are saying for if 2 is not equal to 2, then assign it to my list. If it is equal, do nothing. Basically, the set comprehension is doing like that. So we go for the next iteration now, item equals 3. So we say 3 is not equal to 2. It's true, then assign it to my new list. So my new list is now having the 3. Then item equals 4. So we see 4 is not equal to 2. It's true, therefore insert 4 as well. And in the next iteration, item equals 2. 2 equals 2. So it's not going to be inserted here because 2, we are checking 2 is not equal to 2. And this statement is not true. Therefore, we are not going to insert anything. Then we are having number 5 in the next iteration. 5 is not equal to 2. It's true, so add it. Then 2 is not equal to 2 again, so I'm not going to add 2. Then we are having 6. 6 is not equal to 2, therefore we are going to add it. So this way we created our new list. So this function actually is going to create my new list and return it. And the output of this function is assigned to updated list. So this is my updated list, which is a list that contains these elements. And basically here we are simply printing this list. So the updated list is 1, 3, 4, 5, and 6. 1, 3, 4, 5, and 6, and 5 and 6. So this is exactly what I expected. But now the target was 2. So what if the target is 5? So it means that I want to create a new list without having number 5 in it. So when I run the code, we see that now 1, 2, 3, 4, 2, 2, and 6. So 5 has been not considered to be inserted in my updated list, but number 2 has no problems now because I chose simply to remove number 5. And if I wanted to have number 1 as the target element to be removed, so when I run, we see that number 1 is not there anymore. Basically, this is how we can remove all occurrences of a specific element from a list. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to get the largest number from a list. So here is my list. As you see here, the list contains these elements. So there are 6 elements in this list: 10, 25, 78, 45, 89, and 23. So when I run this code, we see that it says the largest number in the list is 89. So basically, here we are finding the maximum number in the list, and this is what we wanted to do. But how can we do it in Python? So there is a built-in function in Python that is called max, and this function can help us to find the maximum number. We are having the max, and in parentheses we are having numbers. So we are having our list being in the parentheses. So this max function is going to find the maximum number that is there in the list numbers, and then it is assigned to largest variable. So variable is called largest, and that max number that is found from this numbers list is going to be assigned to the largest. And basically here the largest number is 89. So 89 is assigned to this variable, and then 89 is being printed here. So this is the easiest way to do it. However, there are other methods that we can do this. So another method that we can think of is the following. So here I am having my list called numbers being converted to a set. So if there is any duplicate, it is going to be removed. Then it is going to be assigned to, it is going to be converted to another list again, because we were working with a list. We would like to keep it with list. And this is going to be assigned to my new list. Okay. So now why did I do that? So this way, because sets are having this feature that they cannot have duplicates, and it's very important. Because, for example, we are having a list, and this list is having, for example, number 20, 20, 13, 15, and these are my numbers. And usually, when we are having a set, we are not going to have a duplicate. So it's one of the features. They are not going to allow you to have duplicates. So now if I want to find the second largest number in my list, it should be, when I sorted it in descending order, it should be the second element. But because I'm having duplicates, there is a problem there. So duplicates should be removed before finding any numbers in my list. If I'm looking for the third smallest element or the fourth largest element, etc., duplicates must be removed. So now I see that the second element is the second largest number, for example. No, because now it's not sorted. We need to first sort it as well. So now I would have the sorted list, and now it is equal to 20, 15, and 30. So we see that now the second element, after removing the duplicates and then sorting it, we see that here we are having the second element being the second largest element in this list. So it's important, if you are looking for the third largest number or second smallest number in a list, it's very important to first remove the duplicates and then sort it. And in order to remove the duplicates, the easiest way is to convert it to a set, because sets cannot have duplicates, and then convert it back to lists and assign it to a new list. So now my new list is called my new list. This is the name. And if I print my new list here, when I have my new list, for example, in the print, so if I print it here, so let me comment these parts. So you see that this is my new list, and this list has no duplicates. Actually, the original list here was not having any duplicates, but I can have these duplicates. So I'm having 223. So there is a duplicates here, and I'm having two number 1. So if I run the code, you see that 23 is only there one time, and number 1 is also there only one time, and it's not repeated anymore. Okay, so duplicates are now removed. This is the print of my new list after converting it to set and then converting it back to list. So duplicates are automatically removed. Then because I'm looking for finding the maximum number, I need to sort it in descending order. And now that I'm sorting it in descending order, in order to do that, first I write down my name, then the sort function is called. So in the parentheses, I'm having reverse equals true, meaning that it is going to sort the list for me. So now if I print one more time my list, here you see that after sorting, we are having 89, 78, 45, etc. until the end. So it's sorted in descending order. And finally, if I'm looking for the maximum number, so we are here looking for the largest number in the list. Here, we can write down the name of our list and index 0, because index 0 represents the first element, and because we are having a sorted list in descending order with no duplicates, the first element is the largest element. So when I run the code, you see that number 89 is being printed in the output. But if I was looking for the second largest element, I could simply write down index 1 here. And because we already removed everything, the duplicates, we shouldn't be worried about it. So 78 is there. So if I write down number 2, it's going to give me the third largest number, which is 45, which we see here. So this is how we can find the largest number in a list, or any other largest number, for example, the second largest, the third largest, etc. And if in case you're looking for the smallest number, you can simply use the -1. It is the last element in our list, and because we are having a list in descending order with no duplicates, the last element is going to be the smallest element. So -1, if you write it down, you're going to have the smallest number. If you write down, for example, -2, you're going to have the second smallest number. You see, number 10 is being printed in the output. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to count the number of strings from a given list. For example, the criteria is to have the first and last characters to be the same. For example, here I'm having a list of strings. Here are my elements. A, B, C. This is my first string. So the first character is A. The last character is C. And they are not equal. So A is not equal to C. So this is not something that I'm looking for. Again, here, X, Y, Z. X is the first character, Z is the last character, and they are not equal. So this is not also what I'm looking for. But here I'm having A, B, A. So the first element is A, the last element is A, and the first element equals the last element. So this is what I'm looking for. Okay, so I would like to count the number of strings that are having the first and last characters to be the same. So this is the first one, this is the second one, and this is the third one. And in the output, we see that there are 3 strings in my list that are having the first and last characters to be the same. So this is what I'm looking for. When I run the code, I would like to get this number. So number of strings meeting the conditions is 3, and 3 is meaning that I'm having 3 elements in my list that are a string, and their first character and last characters are the same. So 1, 1, M, M. Okay. In order to write that, first of all, I need to initialize a counter. So my counter equals 0. Then we need to loop through our list, which is called words, and my iterating variable is word. So here I'm having the iterating variable word for each word that is in my list called words. If the first element and the last element are equal, okay, if both of them are equal, increase the value of count by 1. So count equals 0 initially, it is going to increase this value. And finally, we're going to print this count in the output. So if I want to show you the indexing here, this is my list, and this is having index 0, this is having index 1, index 2, index 3, index 4, and index 5, okay? Then I'm having the reverse indexing as well. So we can call this -1, -2, -3, -4, -5, and -6. So this is also the indexing. If I start from right in Python, we can have that. So this last string could either be called with index 5, or it could be called by index -1. The same thing with the first element. So it is the index 0 or -6. Okay, but when we are looking from left to right, it's not easy to understand that, okay, this one is -6 or -5, etc. So index 0 is the best way to understand the first element and to print the first element, for example. So whenever we are dealing with the first element, we are going to use the index 0, and whenever we are working with the last element, simply we are going to use the -1 index. And why did I mention that? Because now here we are checking this condition. So if the first element, this 0, equals the last element, you please increment the value of 1. And here, this is the indexing of my elements in my string. But what I am actually looking for is the indexing in each individual string. So in this string, we are having 1, 2, 3. So 0 is the index of A, 1 is the index of B, and 2 is the index of C. Similarly to the above rule that I just explained, we can have -1 for the C, -2 for B, and -3 for A. Okay, so A could have the index 0 or -3. C also could have the index 2 or -1. And based on this law that I just explained to you, we could have the call for the first element simply using the index 0 and the last element to have -1. Okay, so here when we are iterating over each string, so here word in the first iteration equals word equals ABC. Okay, and we are checking to see if A equals C. So the answer is no. The answer is no. So it's not going to increment the count. Okay. In the next iteration, word equals XYZ. If X equals Z, the answer is again no. Then we are having word equals ABA. If A equals A, so the answer is no. Word equals 1221. If, sorry, here the answer was yes. I made a mistake, sorry. So here we are saying that the word equals ABA, and we are saying if A equals A, so yes, because this condition is true, this condition is true, we are going to increase the value of count. So now count equals 1, okay? So count equals 1 now. Then we are having this next, in the next iteration, the word equals 1221, and we are checking to see if 1 equals 1, and the answer is yes. So because the answer is yes, this statement is true, and then we are going to increment the value of count. So now count equals 2. Then in the next iteration, we are having word equals hello if H equals O. The answer is no, so they're not equal, so we're not going to do anything. We go for the next iteration. And finally, word equals mom, and we are checking to see if m equals m. So the answer is yes. Because the answer is yes, we are going to increase the counter one more time. So now the counter equals 3, and we reach the end of our list. So we iterated through all the elements, and finally here we are going to print this message, number of a string meeting the condition. This is exactly what is being printed here, and we are having the count, which is here. Okay, so it's 3. If I add another element, for example here, for example r as h, we see that there should be again the same number of repetition. The count is 3 because here the first element r and the last element h, they're not equal. But if I have, for example, oops, sorry. So if I have, for example, r h r, for example, now I expect to see this to be 4 because we added another element to the end of my list, and it has r as the first element and r as the last element. Therefore they are equal when we are iterating and we are incrementing the value of count, so it will become 4. Basically this is how we can understand how many string in my list of a string are there that are having the first element and last element to be equal to each other. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to remove duplicates from a list. So here is my list called numbers. We are having 1, 2, 3, 4, 2, 5, 1, 6, 3, and 7. As you see in my list, there are some duplicates. For example, number 3 is repeated 2 times. Number 2 is repeated 2 times, for example. Number 1 is repeated 2 times. And yes, these are the duplicates. These are the only duplicates that we have. But we would like to remove the duplicates. Well, how can we do that? So the first way to do that is to simply convert my list to a set, and then from a set back to a list. Okay, so one of the feature of sets is that they do not allow duplicates, and they do not allow to have, for example, 2 elements with number 2. And you cannot have this in a set. For example, you cannot have these many number 2s. You can only have unique values. You can have number 2 but one time only. That's it. So in order to benefit and profit from this feature, we can simply convert our list to a set. So automatically the duplicates are removed, and then convert it back to a list again here and assign it to a new list called unique numbers. This is the new name of my list, which contains the unique elements of the numbers list. And here I'm printing it out. So print list after removing duplicates, and we're printing the unique numbers. So when I run, you see that this new list is exactly this one without duplicates. So we see that number 1 is only there one time, number 2 the same, 3, 4, 5, 6, and 7. So we have no duplicates. So the easiest way to remove duplicates from a list is to simply convert it to a set and then convert it back to a list. But there is another way to do it. So let me comment this part. The second way to do that is the following. Here is my list. Okay, so you see that it's the same list. I'm having a list called numbers with the same elements here. Okay, now I am initializing an empty list to store only the unique elements of my numbers list. Okay, I say it one more time. Here I am initializing an empty list. You see it's empty, to store the unique elements of the numbers list. So if there is any duplicates, I'm not going to insert into my new list called unique numbers. Only the unique elements are inserted. But how can we do that? We need a for loop. We are going to loop through the original list, which is called numbers, and then in each iteration we are checking to see if that number is already inserted in the unique numbers or not. If not, we are going to append it. Otherwise, we're not going to do it. So let me illustrate it with an example here. Here we are checking, we are iterating for each number in numbers list. So in the first iteration, for example, num equals 1, because the first element is 1, for example. We are checking to see if 1 is not in unique numbers, because it was empty, it was not. So 1 is not already existing in the unique numbers because it is empty. So now that it's empty, and number 1 is not already there, we are going to take that number and append it to my unique numbers. So now the unique numbers has been updated, and it has the number 1. Okay, in the next iteration, num equals 2. Num is not in unique numbers. Is it true? Yes, because it only has one element, and that is 1. Now that it's true, append that number to my unique numbers list here. Okay. In the next iteration, we are having the number 3. So in the next iteration, we are having number 3. Number 3, we are checking if it's not already in the unique numbers. This is my unique numbers. Number 3 is not there. So I'm going to append it as well. So we are going to append that number into my unique numbers list. And then we are having the next iteration. In the next iteration, we are having num equals 4. So num equals 4 here. We are saying that 4 is not in unique numbers, and unique numbers is having 1, 2, 3, and it's not having 4. So we can append that. So we are going to append number 4 into unique numbers. Okay. Then in the next iteration, we are having number 2 again. So number 2, now num equals 2. So we are saying 2 is not in unique numbers. Is it true? No, it's not true because it's already there. Therefore, this condition is not true and we are not going to execute this part. We are going to for the next iteration. Now num equals 5. Now num equals 5. We are having 5 is not in unique numbers. Is it true? Yes, 5 is not there actually. So I'm going to add 5, appending 5 here. Then in the next iteration, I'm having element 1. Element 1 is there. 1 is not in unique numbers. This is unique numbers. Is it true? No, it's not true because 1 is already there. So because this condition is not true, we are not going to execute this part. We're going to go for the next iteration. Now element 6. So num equals 6. We are checking 6 is not in unique numbers. Unique numbers. Yes, it's not having the number 6. So we are going to append number 6 into the unique numbers. Okay. The next element is number 3. We are going to have num equals 3. So 3 is not in unique numbers. 3 is not in unique numbers. Is it true? No, it's not true because we already appended number 3. So we are not going to insert that. So because this condition is not true, because 3 is not in unique numbers, this is what it says, but it's not true because 3 is already there. Therefore, we are not going to execute this part. We are going for the next iteration. In the next iteration, the num equals 7. 7, and here we are checking to see if num is not in unique numbers. So 7 is not in unique numbers. Yes, this statement is true. We are going to write down 7 there, and we are going to append 7 into the unique numbers here. So this is my unique numbers list that I created here, and as you see, when I run the output, that after this for loop is having, so after this for loop is finished, the unique numbers list is updated like this, and simply we are having the list after removing duplicates, and we are printing it 1, 2, 3 until 7, and this is what we expected, 1 until 7, 1 to 7. So this is how actually we can create a new list using by removing the duplicates using for loops. But the easier way, the easier method, as I mentioned there, was to use the conversion to set and conversion back to list. But this is another method that it's good to know about. So you can use for loops and use if conditions to only append the unique elements. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to print the numbers of a specified list after removing even numbers from it. So here is my list. It has these elements. See 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we are intending to remove the even numbers. So in order to remove even numbers, we can simply use the list comprehension to filter out the even numbers. So here we are saying that for each num that is in the numbers, okay, if num is divided by 2 and the remainder of this division is not equal to 0, we're going to create a new list called filtered numbers. Okay, so in each iteration, basically what is happening here is that it says, for example, num in the first iteration equals 1. It says num if it's divided by 2, the division the remainder of this division is not equal to 0. Is it true? Yes. So add it to filtered numbers. So filtered numbers is having number 1. So before discussing that, we know that the definition, even number. A number is even only if it is divided by 2 and the remainder of this division equals 0. This is a definition of even number. If it's not true, that number is odd. So if a number is divided by 2 and the remainder of this division equals 0, it means that that number is an even number. Otherwise, it's an odd number. Okay, and in order to find the remainder of a division, we are going to use the modulo operator. So in the first iteration, number 1, if it's divided by 2, the remainder is not equal to 0. Yes, it's true. Therefore, we are going to add that number into the filtered numbers. Okay, and 1 is there actually when we are printing the filtered numbers. In the next iteration, num equals 2 because the next element is 2. So we are checking to see if 2 is divided by 2, the remainder is not equal to 0. It's not true because when 2 is divided by 2, the remainder equals 0. Therefore, 2 is not going to be inserted in the filtered numbers. Okay. Then we are having the next element, which is 3 in the next iteration because we are having a for loop here. Yeah. So in the next iteration, we are saying 3, if it's divided by 2, the remainder is not equal to 0. Is it true? Yes, it's true. Therefore, add that to the filtered numbers. And we see that in the end, when we are printing it out, we see number 3 there. Then the next element is 4. 4, if it's divided by 2, the remainder of this division is not equal to 0. Is it true? No, it's not true. 4, if it's divided by 2, the remainder is 0 indeed. So it's not going to pass this condition. Therefore, it's not going to be inserted into the filtered numbers. You see that 4 is not there. In the next iteration, we are having number 5. Number 5 is there. So we are checking to see if 5 is divided by 2, its remainder is not equal to 0. The remainder of this division is not equal to 0. Yes, that is true. Therefore, 5 is added to filtered numbers. Okay. Then the next element, because we are having, I'm saying that the next element because we are in this for loop. Okay. So for each num in the numbers, and this num is my iterating variable. So it is going to start from 0 here. Start from here with element 1 and it is going to continue up until 10. So it is iterating through these numbers. So now num equals 6. 6, if it's divided by 2, it's not equal. The remainder of this division is not equal to 0. Is it true? No, it's not true. This sentence is not true. This sentence is wrong. Therefore, 6 is not entered into the filtered numbers because 6 is divided by 2. The remainder is 0. So when 6 is divided by 2, the output is 3. Okay, the output of this division is 3. But when the remainder of 6 divided by 2, it is equal to 0. Okay, this is the output. So here, after that, we are going to iterate again over the next element, 7. 7, if it's divided by 2, the remainder is not equal to 0. Yes, it's true because the remainder of 7 divided by 2 is 1. So therefore, this statement is true. So it is inserted in the filtered numbers, you see. Then for number 8, 8 is if it's divided by 2, the remainder is not equal to 0. It's wrong. It is indeed equals to 0. Therefore, it's not going to be added to the filtered numbers. And finally, here for the last element that will be inserted in the filtered numbers, 9, if it's divided by 2, the remainder of this division is not equal to 0. Yes, it's true. So filtered numbers is number 9 is added to the filtered numbers. Finally, number 10 there, if it's divided by 2, the remainder of this division is not equal to 0. It is not correct. So indeed, the remainder of this division equals 0. Therefore, 10 is not added to the filtered numbers. And we see that we don't have it here. So in this video, we learned that we can write a Python program to print numbers of a specific list after removing even numbers from it. So this is how we filtered the even numbers from the original list, and we created our new list called filtered numbers, and the filtered numbers is being printed here in the output. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to multiply all the items in a dictionary. So here is my dictionary called NumDictionary. We see that here in dictionary, as we remember, we were having key value pairs. So here the key is A, the value is 2, the key is B, value is 3, the key is C, the value is 4, and the key is D and the value is 5. So we would like to multiply all the values here. So 5 multiplied by 4, multiplied by 3, and multiplied by 2. So 5 multiplied by 4, it's 20. 20 multiplied by 3, it's 60. Multiplied by 2, it will become 120. So when we run the code, we see 120 in the output. But how can we do that? First of all, in order to do that, we are initializing a variable called product to 1. Now that we are initializing product to 1, we are having a for loop and we are iterating over the values of this dictionary. Okay, only the values. And in order to iterate through the values, I write a for loop. So value is my iterating variable. For each value in the dictionary, NumDictionary, we use the values function. So whenever we want to access the values of a dictionary, we should write down the name of the dictionary dot values. Okay, so here it is possible now for us to access the values that are inside this dictionary. So now we are having an iterating variable that is iterating over the values of my dictionary. Okay, and the values are 2, 3, 4, and 5. And in each iteration, that iterating variable is added to the product. So it is multiplied by product and it is added to the product. So for example, in the first iteration, so first of all, we are having this. So product star equal value, it's the same as this one. Okay, product equals product multiplied by value. Okay, they are the same. Okay, so in the first iteration, value equals 2. Why? This is value, my iterating variable. In the first iteration, it takes the first value, okay, in the dictionary, and it is equal to 2. Therefore, we are going to have product multiplied by value. So product is 1 multiplied by 2, the result is 2. So the formula is this one, product equals product multiplied by value. So product is 1 because we initialize it to be 1. And then value is 2, and we see that number 2 is the value because we are in the first iteration and the first value in the dictionary is 2. So 2 multiplied by 1, it's 2. Then we are having the second iteration. So value equals 3. We are going to have 2 multiplied by 3. Okay. So why 2 multiplied by 3? Because we are having product multiplied by value. So 2 is the product number, which is here, and 3 is the value in the second iteration. In the second iteration, we are having the second value there. So it means that 2 multiplied by 3, it is 6. Okay. Then we are going to have the third iteration. So value equals 4 now. Why? Because we are in the third iteration and the third value in my dictionary is 4. So 4, we are having it here. So 6 multiplied by 4, we're going to have 24. Okay, 6 comes from the product multiplied by value. So 6 comes from the product in the previous iteration, and 4 comes from the value that we are having in the third iteration, and this is the value, so it will become 24. And finally, in the fourth iteration, we are having value equals 5. Why? Because we are in the fourth iteration and the fourth value is 5. So first value, second value, third value, and the fourth value. And therefore, we are going to have 24 multiplied by 5, and it will be 120. So we had an iterating variable iterating over all the values of this dictionary, and in each iteration it was multiplying that value by the product. Initially the product was 1, but in each iteration we were updating the product, so then it became 2, 6, 24, and finally 120. So 120 is stored in the variable called product here, and here we are printing the product. So we are saying that print, we are using the print function, the product of all values in the dictionary is, then we are typing down the name of the variable product, which is 120. So this is how we can compute the multiplication of all the items in a dictionary. This is one way. Also, there is another way to do so. So let me comment this part. So in order to do that in an easier way, we can do this. So let me comment this part also. Okay. So another way to do that is this. So first of all, we are going to import the math library because we are going to use some of the functions. So here is my dictionary. It's the same dictionary. It's A2, A with 2, A2, B3, C4, and D5, as you see here. So there, it's an exact same dictionary. Instead of having a for loop here to calculate the multiplication of all the values in my dictionary, there is another easier way to do that. We can use the product function. So if we want to use the product function, we are going to import the math library. So we are going to write down math.product, meaning that call the product function from the math library. Then in parentheses, we are going to write down this. So name of the dictionary dot values. Values meaning that we are going to have access to the values associated to this dictionary. And these are the values of my dictionary. You remember we said that in dictionaries we are having key value per. Okay. So key, its value, key value, key value, key value. So we are going to access the values of the dictionary called numDictionary, and we are going to call the product function from the math library to calculate the multiplication of all the values in this dictionary, and the output of this is assigned to product. Then we are printing the product. So if I run the code, we see exactly the same number in the output. So it's easier to use this built-in function if you find it interesting. Otherwise, you can of course use the for loop in order to have your calculation. So it depends on you. If you find this method more interesting, you can use this one. Otherwise, you can use this method. But remember that you need to import the library math. Thank you for watching. Welcome back. In today's video, we would like to write a program that finds the key with maximum value in a dictionary. So here is my dictionary. It is called scores. We see that in my dictionary, as always, we are having key value pairs. Okay, so this is one pair, this is another, sorry, this is another pair, this is another pair, and this is another pair. Okay, so Alice is my first key. Its associated value is 85, Bob 92, Charlie 88, and David 76. So this is my dictionary that has 4 key value pairs. My aim in this coding exercise is to find the maximum value in the dictionary. So you see that these are the values: 85, 92, 88, and 76. I would like to find the key that corresponds to the maximum value in the dictionary, and the key is Bob. Okay, so this is the maximum value. I would like to print its key, which is Bob here. Okay, so how can we do that? In order to do that, I'm creating a variable here called highest scorer, and then it is assigned to the call of function max value key, and as the argument I am passing the dictionary. So dictionary is passed as a dictionary to call max value key function. This max value key function is called and it is initialized and created using the def keyword, and it has one argument, which is the dictionary here that we have. We call it in the dictionary, we call it data. So this function is going to find the maximum value of this dictionary and return its key for us. How? We need to use the max function. So in order to do that, we use the max function. And in parentheses, first of all, we are having the name of the dictionary, and we call it here data. We can call it whatever. It can be data, data2, my data, my dictionary, anything. It's your choice. So we are going to use the max function, and we are going to call this max function with two arguments. The first one is the name of the dictionary, and the second one is this key equals data.get. So we are going to get the key, the maximum key of the data dictionary. Okay, so we are going to get the maximum key in the data dictionary. Okay, so this is how this max function is going to work. And then it is going to return us the key. For example, here the maximum key, the maximum value is 92, and it is going to first of all find the maximum value in this dictionary, which is 92, and here we are going to say the maximum value is 92, get me the key to this 92, and it is going to return Bob, and Bob is returned as the output of this function, and the output of this function is assigned to highest scorer, and here we are printing it out. So person with highest score, it's highest scorer. So highest scorer is being printed here, and we see that Bob is the highest scorer. But if I have, for example, Charlie to have the score of 100, and when I run the code one more time, we see that person with highest score, it is Charlie. Why? Because now the highest value in this dictionary is 100, and we are going to get the corresponding key to the maximum, we are going to get the maximum value, finding the maximum value, and return the key that is associated with the data dictionary. Okay, and basically we are first of all finding this 100, and it is going to return us Charlie, its associated key, and Charlie is returned. Therefore the output of this function when we are calling it using this dictionary is scores, we are calling the max value dictionary and passing scores as the argument, and the output of this is assigned to highest scorer, and highest scorer is being printed out here in the output. So if I have another function here, another dictionary, for example, if I call it scores 2, so here Reza is, for example, 92, Bob is still there, Bob is 90, Charlie is still there, Charlie is 67, for example, and David is there, and David is, for example, this time 80. So here, who is the person who has the highest value? So Reza is the one who is having the highest value. Okay, now I would like to call the max value key function, but pass this scores to dictionary and not the first dictionary. Okay, now I'm calling the function using the scores to dictionary. So if I run the code, we see that now the answer is Reza, because now I am calling this function using this dictionary, which is scores to. And you can have many different dictionaries, and you can have different calls for the dictionary. Now I can have, for example, dictionary number 3, where, for example, David has, for example, 99, the score of 99. And here I am calling the function using the score 3, and I am calling it highest score 3. So here, highest score 3 in the third dictionary. So if I run the code, you see that we are having David being printed because we are having a third dictionary in which David has the highest value, and we are calling the max value function with this dictionary and assigning it to highest scorer 3 variable, and this variable is being printed out here. So the person with the highest score in the third dictionary is David, because David has 99. So basically in this video we learned how we can find the key with the maximum value in a dictionary. Thank you for watching. Welcome back. In today's video, we would like to write a program that merges two dictionaries. If a key exists in both, sum their values. So here is my first dictionary. It has 3 key value pairs. Key A has value 100, key B has value 200, and key C has value 300. Then we are having the dictionary 2, has 3 again key value pairs. Key B has the value of 100, key C has the value of 50, and key D has the value of 400. Now we see that here it says if key exists in both, sum their values. So now we would like to create a third dictionary in which, for example, here dictionary 3, we would like to have a third dictionary in which we are having A, it's 100. We are having B, it's 350. Why? Because we are having B here and here. And the program says if key exists in both, sum their values. So it's 200 and 150, so it will be 350. So, and then we are going to have C, which is 300 in the first dictionary and 50 in the second dictionary, so it will become 350. Finally, we are having D, we are having D, which is 400. Okay, so we would like to create a third dictionary merging these two dictionaries. And if one key exists in both of them, we are going to sum their values. But how can we do that? Manually, of course, we can do it very easily. But how can we do it using Python? In order to do that, we are having a function called merge dictionary, and we are passing two arguments, first dictionary and the second dictionary. And what we are doing here is the following. When this function is called, first of all, we are copying everything of the first dictionary into a new dictionary called merged. Okay, so here we are creating a dictionary called merged, and it has all the values of the first dictionary. So we copied everything there. Okay, so now I created the merged dictionary. Now the main part is here. So we are going to have two iterating variables, key and value. We are iterating through the items of the second dictionary. And we know that when we are using the items function, it means that we are going both through the key and values. So this key is iterating over the keys of the second dictionary, and this value is iterating over their corresponding values in the second dictionary. Okay, so now we are having two iterating variables. We are iterating over all the key value pairs of the second dictionary using the items function. Now when we enter this loop, we are going to check and see if the key is already inside the merged dictionary, which we created here. If this is true, get the value of that key from the merged dictionary and add the value of the same key from the dictionary too. What do I mean? So here, let me illustrate it with an example. In the first iteration, key equals B, value equals 150. Do we agree? Why? Because key and value, they are iterating over the second dictionary. Okay, second dictionary is this one, and here we are having the key value pair. So the first key and the first value are B and 150. So we are having in the first iteration key equals B, value equals 150. Okay, this is the first iteration. And here we check to see if we already have that key, which is B, in the merged dictionary. Do we have it here? Yes, we are having it here. Okay, so now that we are having it already here, get this 200 value for the key B, which is here, from the merged dictionary. Okay, so get that 200 and add it. So we're going to have 200 plus, add it to the value, which is 150. Okay, which is 150. Now, by doing this, the value of the key B, okay, which is B here in the first iteration, in the merged dictionary is updated. Now it is 350. Okay, so in the second iteration, what is happening here? Second iteration, the key equals C, value equals 50. Yes, do we agree on that? So in the second iteration, we are having two iterating variables, key and value. Key equals C. Why? Because the second pair in the dictionary 2 is C and 50. So key is C and value, its value is 50. Okay. Now, what we are doing here is the following. We are checking to see if the key, which is C, already exists in the merged dictionary or not. Yes, already exists because we are already having a key C there. So now that it exists, get the value of that key from the merged dictionary, okay, and add it to the value which is 50. So we are going to have 300 plus 50. Okay, so we are going to use the get function to find the value of that key from the merged dictionary and add it to the value, which is the value from the same key in the second dictionary, and all of that is assigned to the same key of the merged dictionary. Okay, and the merged dictionary is this one and the key is C. So basically this get function is getting the value of the key C from the merged dictionary, which is 300, so this part, and add it, okay, and add it to the value, and value is 50. Okay, so 300 plus 50, it will be 350. Okay, so it will be 350. Now it is going to be updated and 350. And in the last iteration, so third iteration, we are having key equals D, value equals 400. So here in the dictionary 2, in the last iteration, the last pair is D400. So D400, okay? So we are having here, we are checking to see if we are having this key, which is D, in the merge dictionary. Do we have it here? No. Now that we don't have it here, we are going to by default assign number 0. This is why we are having it 0. So if that key exists in the merge dictionary, we are going to return the value. Otherwise, we are going to return 0. So in the previous iteration, if you remember, we were discussing the key C. So key C, was it existing already in the merge dictionary? Yes. So return its value. So it was 300 plus the 350. So it was 300 and it added to 50. So it became 350 that we updated here. Okay. But if we are investigating a key that already is not existing in the merge dictionary, using the get function, we are going to assign number 0 by default. This is why we are having number 0 here. So we use the get function to get the value of that key, which is D here, from the merged dictionary. Because it's not there, we don't have the key called D, we are returning 0. And we are therefore adding 0 plus 400, which is the value of the key D in the second dictionary. In the second dictionary, the value is 400. Okay. So therefore, we are having a new key being created, D, with the value 400. So 400 plus 0 is assigned to the key D in the merged dictionary. Okay, so we created a new pair here, the merged D, and here we were getting the value of that key from the merged dictionary. Because we were not having that key, we returned 0. And basically this is how the get function works, and we added to the value, which was 400. So now we added the last pair as well. So this function, basically using one line in the for loop, we could complete the merged dictionary. And finally, in the end, after this for loop is finished, this function is going to return the merged dictionary. And the output of this function, when it is called, is the merge dictionary, and it is assigned to the variable called result. So result is my new dictionary, that is the output of the merge dictionary function, and we are here printing out the results. So merge dictionary, and here exactly what we expected. So A is 100 because A is only there in the first dictionary. D is 400 because D is there. And B is 200 plus 150, it's 350. C is 300 and this is 50, so this is 350. So this is how we could write a program that merges two dictionaries, and if a key exists in both, we are going to sum their values. So this function was there to help us doing so. First of all, we copied the first dictionary in the merged dictionary, and then we iterated over the key and values in the second dictionary, and we added them to the merged dictionary. In each iteration, we updated it. Thank you for watching. Welcome back. In today's video, we would like to write a program that removes keys with a specified value from a dictionary. So here is my dictionary. It is called products, and it has 4 key value pairs. The first key is apple, its value is 50. The first key is banana, its value is 0. The second key is banana, sorry, and its value is 0. The third key is cherry, its value is 75, and the fourth key, sorry, is date, and its value is 0. So this is my dictionary. Now I would like to create a new dictionary from this dictionary and remove the key value pairs when a value has the value of 0. So we see that here banana and date are having value 0. I would like to simply remove them because they are equal to 0. I don't want to have them, and I would like to update my dictionary with only having the keys that are having some value, some meaningful value. So the filtered dictionary is apple 50 and cherry 75, apple 50 and cherry 75. So these two are removed. How can we do that? In order to do that, I call a function called remove keys with value, and two arguments are passed. So the first one is my dictionary and the second one is 0 because I would like to remove any keys that has a value of 0. This is why I'm passing 0 there. Then in this dictionary, as we mentioned, we are having two arguments, data and target value. So data is the name of my dictionary in this function. We can name it as we want. And target value is number 0 that I don't want to have keys with this value. So here we are using the dictionary comprehension. So we are saying that create a new key value dictionary for me for each key and value that is inside the data dictionary, which is my product dictionary. And in the function, simply I call it data because it's the first argument. And we see that the first argument for the call is product dictionary. So we see that this is the dictionary. So for each key and value in the data dictionary that we are iterating using the items function, meaning that we are iterating over the key and value. So the key is going to iterate over the keys and value is going to iterate over the values. Okay, so for each key and values that are in the data dictionary, if the value is not equal to the target value, then insert it into my new dictionary, meaning that in the first iteration, key is apple. Okay, in the first iteration, key is apple, and its value is, let me write value, its value is 50. So key is apple, value is 50. We are saying that if value, which is 50, is not equal to the target value, what is that number? It's 0, the second argument. Okay, so 50 is not equal to 0. Yes, it's true. Therefore, insert it to my dictionary. Okay, key value. So apple and 50 is added to the dictionary. So we are having apple and 50. Then in the next iteration, we are having the key equals to banana and the value equals 0. So now we are saying if value is not equal to the target value, the value is 0, the target value is also 0. 0 is not equal to 0. Is it true? No, this statement is not true. Therefore, we are not going to insert this key and value pair to my dictionary. So we go for the next iteration. In the next iteration, the key is cherry and the value is 75. Okay, so we say key is cherry and value is 75. In the next iteration, we check if 75 is not equal to 0. Is it true? Yes, it's true. 75 is not equal to 0. Therefore, insert them into my dictionary, key and value. So now I'm adding cherry with the value 75. So this is the next one. And in the next iteration, the key is date now because this is the next iteration. So it is date. And its value is 0. So in the next iteration, we check 0 is not equal to 0. Is it true? No, it's not true. 0 equals 0. So we're not going to, because it's not true, we are not going to insert the key and values. So we created a dictionary with two pair of keys and values. So apple and 50 and cherry and 75 and return it. So this is the place that we call this function with two arguments. So we are going to return the output, which is this is the dictionary that is output of the remove keys with value dictionary, and this is assigned to the filtered dictionary. Okay, so the filtered dictionary is now having these two key value pairs. So filtered dictionary equals. Okay, so filtered dictionary equals. So the filtered dictionary is now created. And simply we are saying that filtered dictionary, and we are printing it out in the output. Basically, this function can help us to create a new dictionary and avoid any key value pair with a specific value number. For example, here I was calling the function. The first argument was the dictionary. The second argument was 0, meaning that I don't want to have any keys in this dictionary to be there anymore if its value is 0. But if I want to remove for example, if I want to remove the keys that are having the value 75, so I pass number 75. So when I run the code, we see that in the filtered dictionary, we have everything but cherry. Cherry has the value 75, and I didn't want that because I put 75 there. So we see that in the filtered dictionary, we are having everything. Apple is 50, we are having it. Banana is 0, we are having it. And date is 0, and it's there. But cherry is not there because the criteria for filtering of the dictionary has changed now. Now I want to exclude keys that are having value 75. So this is basically how we can filter a dictionary with a specifically with a specified value. Thank you for watching. Welcome back. Here we would like to write a program that swaps the keys and values in a dictionary. So, for example, here is my original dictionary. We see that there are 3 keys and 3 values. Okay, so 3 pairs are there, 3 key value pairs, let's say. Okay, here is that. So for Alice, we're having manager. For Bob, we're having engineer. For Charlie, we're having the designer. Now I would like to swap the value with the key in each element. So the keys must be swapped with the values. So in the output, we see that instead of having Alice manager, we are having manager Alice. Instead of having Bob engineer, which is key and value, now we are having the new key is engineer and the Bob is the value. So instead of having Charlie designer, we are having designer Charlie. Okay, so this is basically how we want the output to be. So how can we do that? We can use dictionary comprehension. Here we are having the original dictionary, and then I'm calling a function called swap keys values, and we are passing one argument only, and that argument is our dictionary. So this function is going to help us to reach to this dictionary. But how can we do that? So this function is going to have the creation of a new dictionary, and here we see that we are iterating over the key and values of this dictionary. So the keys and values of the data dictionary. The dictionary which was named original, in the function it is called data. We can name it whatever. So we are iterating over the keys and values of the data dictionary. Okay, and what we are returning here is that instead of having the key values, we are having value key. Okay, so let me illustrate it with an example. So in the first iteration, key equals Alice, value equals manager. Okay, so key equals Alice, value equals manager. So we are iterating through this in the data dictionary. So key, which is Alice, and value, which is manager. Now return it instead of having the key value, return it in a value key. So we are swapping their place. So now we are creating a new dictionary where the key is manager, and the value is Alice. Because we learned that in dictionaries, we are having key value pairs. Okay, so key and value pairs. So key and value pairs. So key iterating variable is going to iterate over the keys Alice, Bob, and Charlie. Value iterating variable is iterating over the values of my dictionary: manager, engineer, and designer. Now in the first iteration, key equals Alice, value equals manager, and then we are returning them in the vice versa format. So we are not saying the key value, we are saying value key. If I write down here key, and if I write down here value, when I run the code in the output, we see the same dictionary as the original dictionary. But now I want to reverse their place. So I write down value and key. So this Alice is going to be here, and this manager is going to be here. Okay, so now you see. So now I reversed them. So in the first iteration, we reversed the manager with Alice. Now we go for the second iteration. So second iteration, we are having key equals Bob, and value equals engineer. Okay, so we are saying that for each key and value that is in data, so the key is Bob and engineer is the value. Now return the value and key. So instead of having Bob engineer, we are going to have engineer Bob. So here, the second one is also now set. So we are having engineer and Bob. Okay, so we swap their place. And in the next iteration, in the third iteration, which is the last iteration, we are having this third iteration, key equals, we are having Charlie, and the value equals designer. Okay, the value equals designer. We are saying that, okay, key is Charlie, value is designer. Now reverse their place. So put value and key instead of having key value, put value and key. So here, it will be designer and Charlie. Okay, so now the iteration has finished because we iterated over the three pairs here. So this was the first pair, this was the second pair, and this was the third pair. So we iterated over all the pairs. Now this was the place that we called the function, right? And we passed one argument, which was the original dictionary, and we returned all the output of this iteration, and this is what the output looks like. And this output, because it is on the right hand side, the call of the function, when we return this output is assigned to swapped dictionary. So we are having a dictionary called swapped with these keys and values, okay, with these key value pairs, where we are having manager as the first key and Alice as the first value. But in the original we saw that Alice was the first key, not the value, but manager was the first value and not the key. Okay, so we see that everything is swapped using the function, and it is assigned to swapped dictionary, and here we are printing it out simply. Swap dictionary is this, and this dictionary that you see here, you see exactly is the dictionary that we expected to see in the output. So in this video, we learned how to define a function that can help us to swap the place of keys and values in a dictionary. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to get the maximum and minimum values in a dictionary. So here is my dictionary. this is my dictionary. As you see, there are 1, 2, 3, 4, and 5 key value pairs. The first pair is here. This is the first pair, separated by a comma from the second pair, separated by a comma from the third pair, separated by a comma from the fourth pair, and separated by a comma from the fifth pair. Okay, so this is my dictionary. We are having 5 key value pairs. Now I would like to find the maximum and minimum values in the dictionary. So one value is 10, 25, the other one 5, 42, and 18. So these are the values. So the minimum value is 5, as we see here, and the maximum value is 42. So when we see it, it's easy to find it. However, if you have a very large dictionary, it's not easy to find it manually by looking at it. So we need to have a code, a function that, you know, does the job for us. This is why we use programming, to improve the efficiency, okay, and save some time for ourselves. So in order to do that, we are having some built-in functions in Python. We are having the max and min function. So this is the max function, and here is the min function. Here is the min function. So these are the two functions that we are having it here. So the max and the min. So these are going to help us to find the maximum value in the dictionary and the minimum value in the dictionary. But in parentheses, I would like to have the values, yeah? So I would like to have the maximum values. So I write down the values. So I'm using the values function. Then the values from which dictionary? My dictionary, yes? So I use the value function to access the values of my dictionary. This is the name of my dictionary, and find its maximum value. So using the max function, I'm accessing the maximum values of my dictionary. And this is when it is found, it is assigned to a new variable called max value. And here, similarly, we are having the minimum function to help us. So I'm finding the minimum values, okay, minimum values of my dictionary, So using the minimum function and values function, I'm finding the minimum value in my dictionary. Okay, when it is found, it is assigned to mean value variable that we are having it here. And finally, we are using the print function to show our output. We are having the maximum value and minimum value. So max value, this variable, and the min value, which is this variable, are being printed, both of them in the output. So we see the max value is 42, the min value is 5. So if I change it, for example, the 42 is the max value. If I make it to be 80, for example, when I run the code, we see that the max value is now 80. But if I make it to be like 20, this one is now 20. So D is having the 20. Now, what is the max value? So 25 is the max value, right? So if I run the code, we see that 25 is now having the maximum value. And also for the same goes for the minimum. So for the minimum, if I have instead of having 5, I have 2 and I run, we see that the minimum value is 2. If I have, instead of having 80, if I have 1, the minimum value is now 1. So this is how we can see that by changing even the values, whenever we run the code, we are able to easily and very fast find the maximum value in our dictionary and minimum value. Thank you for watching. Welcome to this video. In today's video, we would like to write a Python program to unpack a tuple into several variables. So here is my tuple. As you see here, it has 3 elements. So we know that in tuples, we need to declare them within parentheses. Okay, so when we want to declare the tuple, we need to define the elements within the parentheses, inside the parentheses. Okay, so here is my tuple. It has 3 elements, 10, 20, and 30. Now I would like to unpack this tuple into several variables. Because it has only 3 elements, we can only unpack it to 3 variables. In order to do that, on the right hand side, I write down the name of the tuple, and on the left hand side, I type down 3 variables that I would like them to get the values of the elements of this tuple. So here I have a tuple with 3 elements. Therefore, on the left-hand side, I have to put 3 variables. So the first element the first element 10, is going to be assigned to A. The second element of my tuple is going to be assigned to B. And the third element of my tuple, which is 30, is going to be assigned to C. And then when I'm having the print and display of my variables here, so when I run the code, we see that the value of variable A is 10, exactly the first element. The value of the variable B is 20, exactly the second element, and 30 for the third element. So what if I have a tuple with 4 elements here? And here I'm having 3 variables. So when I run the code, you see that we are having errors. Why? Because we are having a tuple with 4 elements, but it is being assigned to 3 elements only. So it's necessary to have 4 elements on the left-hand side when we are having, 4 variables on the left-hand side when we are having 4 elements in my tuple. So we can conclude this. The number of variables on the left-hand side must be equal to the number of elements in my tuple when we are unpacking. Okay, unpacking. So here now, when I have 4 elements and I have 4 variables, everything should be okay. I'm going to also print the variable d here so we can see d. So when I run the code, we see that A is 10, B is 20, C is 30, and D is 40. So D is getting the last value in my tuple. So in this video, we learned how we can unpack a tuple into several variables, and we learned that we need to be careful about the number of elements and the number of variables that we are having on the left-hand side. And we learned that the number of variables on the left-hand side must be equal to the number of elements in the tuple if we are unpacking a tuple into several variables. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to create a dictionary from a string. So here is my string. So my string is hello, and it is assigned to a variable called text. Then here is my empty dictionary. Now I would like to have a dictionary being created from the string. But how do I want this dictionary to look like? So I would like to have something like this in the output. We learned that for dictionaries, we are having the key value pairs. Okay, so here you see that I'm having 1 pair here, 1 pair here, 1 pair here, and 1 pair here. So I'm having 4 pairs. H has the repetition of 1, E has the value of 1, let's say, L has the value of 2, and O has the value of 1. So this is my string being inserted into a dictionary, each character of it. So we see H is repeated once, so we are having its value to be 1. E is repeated once, we are having its value to be 1. L is repeated twice, so we are having its value to be 2. And O is repeated once, so we see that its value is 1. So how can we do that? In order to do that, we need to write a for loop. So we are having an iterating variable called char, and we are saying that for each character in my string called text, if that character is inside my dictionary, then increase the counter one value, the counter, and if it's not in this dictionary already, insert it in the dictionary and assign the value to 1. Let me illustrate it with an example. So here my string is hello. Okay, in the first iteration, we are having char equals h. Yes, we are having something like this. So char equals h, because we are going through each character of the text variable, and the text variable is hello. So the first character is h. So in the first iteration, the character equals h. And we are checking to see if h is inside my dictionary. Is it inside my dictionary? No, because it's an empty dictionary. We just created it. So this statement is not true. We are not going to execute this part. We go to the else part. When we go to the else part, what we are doing here is the following. So we are inserting that character h into my dictionary and assign the value 1 to it. So now my dictionary would look like something like this. So char count, we're going to have it like this. Now, after the first iteration, h is inserted and value 1 is assigned to this key. So my key is h because we said that it's a key value per, and my value is 1. Okay, so now we are going for the second iteration. So second iteration, char equals e. Why? Because the second character in my text is e. So here char equals e, we are saying e, is it inside my dictionary? This is my updated dictionary from the last iteration. Do we have a key called e? No, we only have one key and it is h. It's not e. Okay, so this statement is not true. We're not going to execute this part. We are going to the else part, therefore. Because this part is not true, we are going to the else part. Now here what we are doing is that we are creating a key with that character, which is e, in the char count dictionary and assign its value to be 1. So it will be something like this. Okay, so it is something like this. Now we updated our dictionary. In the next iteration, in the third iteration, we are having char equals L. Why L? Because the third character is L. We see L, is it inside my char count dictionary? Char count dictionary is not having the L. So this statement again is not true. We are not going to execute this part, and the else part is going to be executed. And what we are doing here, again, we are creating a key with that character, which is L, and we are assigning the value 1 to it in the char count dictionary. So it will be L equals 1 now. L, its value is 1. Okay. So now we updated the dictionary. We are going for the fourth iteration. For the fourth iteration, char equals L again. Why? Because the fourth character is again L. So we are checking to see if L exists in my char count. So char count, do we have L here? Yes, we just inserted it. So we have a char count. So this statement is indeed true. Now that this statement is true, we are going to do this. So what we are going to do is that for that character L, which is our key in the dictionary and in the char count dictionary, we are going to increment its value by 1. So its value is already 1. I'm going to increment its value by another 1, so it will become 2. Then we go up and we go for the next iteration. So the fifth iteration, this iteration is going to continue until we reach the last element of the string. last character of the string. And now char equals O. Now char equals O. Why O? Because this is the fifth element. Char equals O, so we are checking O. Is it in the char count dictionary? No, we don't have any key called O. We have H, E, and L. So this statement is not true. We're not going to execute this part. We go to the else part, and we are going to create a key with that character, which is O in the char count dictionary. Char count is the name of our dictionary, and assign the value, its value to 1. So it will be something like this. So we updated our dictionary here. So the iteration has finished because we had 5 letters in my string. And here you see that we had 5 iterations. So this has been finished now. And now we are going to print the char count dictionary. And when we run this code, we see that H, the key H has the value 1, as we are having here. The key E has value 1, that we are having it here. The key L has value 2. The key O has value 1. So basically in this video we learned how we can create a dictionary from a string, and we can have a longer string. For example, we could have hello world. So if I run this code, you will see that things will change. So H is 1, E is 1, L is 3, O is 1. We are having 1 space. We are counting the space also. So it's 1, W is 1, etc. We could have another thing. For example, this is the Python coding class with Dr. Reza Shahin. So when I run this code, you see that we are having a long dictionary, and we see that, for example, H has been repeated 6 times. We are having 9 space. We are having the Y only 1 time. We are having T 4 times, etc. So this is a very nice way to create a dictionary from a string with its character. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to check if a given value is present in a set or not. So here is my set. As you see, I am defining my set with 5 elements, 1, 2, 3, 4, and 5. Now here is my given value. So I would like to check if this value is present in the set or not. Okay, obviously we know that it's not present. 10 is not present in the set, but how can we write a Python code to do this checking for us? In order to do that, I am calling a function called check value in set, and I'm passing 2 arguments. The first argument is my set. The second argument is the value that we would like to check its presence. When this function is called, we are defining our function using the def keyword. When this function is called, 2 arguments are there, my set and value. Now here we are checking to see if this value is inside this set. So if value is in set, we are going to print this. That value, which is 10, is present in the set, and if this statement is not true, it means that that value is not inside the set. So we go for the else part and we print this part. 10 is not present in the set. So now let us do the analysis with the numbers. So we are having the value 10. We would like to check its presence in the set. So we are having this check 10 is in this set. Is it there? No, it's not there. So this statement is not true. Therefore, this part is not executed. And this else part is executed, and we are having the print 10, which is our value, is not present in the set, is not present in the set. So this is what we get. But if we are checking number 5, for example, so here we would like to check if number 5 is in the set or not. So 5, is it in the set? We check the set. Yes, the 5 is there. Therefore, this statement is true. Yeah. So the program is going to be executing this part. So the compiler is executing this part, and it is going to print 5 is present in the set. And we see that when we run the code, we are having 5 is present in the set. Basically, this is how we can consider it. And we can have, for example, another set here. I would say my set 2, and it is equal to 2, 4, 6, 8, and 10, for example. Okay, this is my new set. And my value 2 is number 5, for example. Now, when I call the function, the check value in set, I'm using the second set as the argument, and also I use the second value as the second argument. So now I call the check value in set function, and I'm having two arguments, my set2 and value2, instead of this one. So if I run the code, we see that we would like to check if 5 is present in this set. Is it present? No. Therefore, this statement is not true. We're going to see this message. 5 is not present in the set. So we see 5 is not present in the set. But if I check to see if number 6 is there, we see that 6 is present in the set. 6 is present in the set. So this is basically how we can check if a number, a given value, is present in a set or not. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to count the elements in a list until an element is a tuple. So let us look at this list. This is my list. I'm having different elements here. So I'm having number 1, 2, 3. I have a string here, hello. I have a float number there, 4.5. I have a tuple inside my list, and I have number 8 and number 9. I would like to have a Python program to count the elements in the list until an element is a tuple. So they count the elements in the list until an element is a tuple. So how many elements do we have here? 1, 2, 3, 4, and 5. Before we reach the tuple, which is this part, we are having 5 elements. And when I run the code, we see that count of elements before a tuple is 5. So we would like to get that 5. Okay, but how can we compute that? Here is my list. I'm having integers, I'm having float numbers, we are having a string, and we're having also a tuple inside this list. We are initializing a variable called count to 0. So it is initialized to 0. Now, in order to understand how many numbers are there as the elements before that tuple, we are going to have a for loop. So we are having a for loop for each item. Item is my iterating variable. For each item in my list, if the type of that item equals tuple, break. Okay? Otherwise, if it's not like that, just simply increase the counter. So for example, if I want to illustrate it in another way, in the first iteration, item equals 1. And we check the type of the item. So we are checking in the first iteration, we check the type of 1. Is it equal to tuple? No, because it's integer. Okay, so nothing is going to happen. Simply the counter is increased. The counter was initialized to be 0. Now it is initialized, it is increased to be 1. Okay, then we are having the second iteration. So item equals 2. So item 2, here it's an integer again. So we are checking the type of the item, which is 2. And the type of the item is integer. Is it equal to tuple? No, it's not. Therefore, we don't have to break. We are going to increase the count one more time. So count equals 2 now. Then we are having the third iteration. So item equals 3 now, because in the next iteration, third element. We see that here count will be 3. Why? Because number 3 is again an integer. We're checking its type, so it's an integer. Is it equal to tuple? No. We don't do the breaking. We increment the count, so it's now equals to 3. Then we are having the fourth iteration. So item equals hello. This time, hello. So now item equals hello. We check the hello type. It's a string. Is it equal to tuple? No, string is not equal to tuple. We don't do the breaking. We increment the count. So the count equals 4. And the fifth iteration, item equals 4.5. So this time the type of the 4.5, when we are checking it here, it's a float. Is it equal to a tuple? No. So we don't do the breaking. We are going to increment the count one more time. So count equals 5. In the sixth iteration, item equals, you see a tuple. Now we are seeing a tuple there. Okay. We see a tuple there. Therefore, let me also print it here. Print the item. So you see it in the output when I run. So you see that in the sixth iteration, the item is 6 and 7 at the same time, because 6 and 7, they are two elements of one tuple, but they as a whole are included in the list as one element. Okay, so 6 and 7 are two elements of the tuple, but the tuple itself is only one element in the list. If I have another tuple inside this list, for example, another tuple is there, 2 and 3. Although 2 and 3 are two different elements of my tuple, this tuple itself as a whole is only holding one place of elements. Okay, so it is only one element in my list. So this is why we are having it here. So in the sixth iteration, item equals 6 and 7. So 6 and 7. Now we check its type. So this type, when it is checked, it is going to print us the tuple. So the type of this item, is a tuple. So tuple equals tuple. Are they both equal? Yes, they are both equal. Because they are both equal, we are going to break and getting out of the for loop. Okay, so now we are going to break here. Okay, now we're breaking. Why? Because we reached a tuple. We are breaking. Why we want to break? Because we wanted to count the elements in the list until we reach an element. So we were willing to count the elements in a list until an element is tuple. So this element is a tuple, so we don't want to continue, and we were willing to count the number of elements before a tuple show up. Okay, and the number of elements was 5. Because we counted in each iteration, we incremented the value of count 1, 2, 3, 4, 5. In the sixth iteration, we are not going to increase it. Why? Because we are entering this loop, this if condition. We are checking the type of the sixth item, which is a tuple. So this statement is true. We are printing the item, which is 6 and 7, and then we are breaking. So we are getting out of the for loop, and we are not going to increment the value of count because we reached a tuple now. We wanted to know the number of elements before we reach a tuple. Okay, so this is what we are going to get as the output. So the count is 5 because we are printing it here. So when we count also 1, 2, 3, 4, and 5 elements are there in my list before we reach a tuple. And regarding the type, for example, I'm having x equals 10, I'm having y equals 12.5, I have z equals Reza, and I have the type function. So when I have the type function, I can have the type X, type Y, type Z. So now if I want to print them, print the type, we can have in parentheses the print. So it's print and it is printing. So we are printing the type. So when I run the code, you see that the first one, the X is integer, the second one is float, and the third one is a string. So with respect to this function, I wanted to clarify how it works. The way that it works is the following. We are having three variables, one integer, one float, and one string. In order to understand their type, we use the type function and we put in parentheses the name of my variables. And because I want to print this type, I use the print function as well. So we see that the type of X is integer, the type of Y is a float, which is true, and the type of Z is a string here. You see it's in a string. So in each iteration, we are saying integer, is it equal to tuple? No. A string, is it equal to tuple? No. When we were having hello in the fourth iteration, so it was a string. So string, is it equal to tuple? No. So we were incrementing the count. Okay. Or here, in the first iteration, item was equal to 1, so it was an integer. So we were saying integer equals to equals tuple? No. So when the statement was not true, we were not going to enter the if condition, and we were incrementing the value of count because we realized that the item is not a tuple, and we wanted to continue the count until we reach a tuple. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to find the maximum and minimum values in a set. As you see here, here is my set, and we are having a set with 5 elements, 10, 25, 3, 47, and 19. So our set is having 5 elements there, and we would like to find a maximum element, an element with maximum value, and another element with the minimum value. So the maximum value in this set is 47, and the minimum value is 3. We would like to find these two values, and we see that in the output we are having them being printed out. But how can we get that? In order to get that, so here is my first set, my initial set, let's say. I call a function called maxmin, find maxmin, and we are passing my set as the argument. And we see that this is the call of the function with argument on the right hand side, and on the left hand side we are having two variables. Okay, on the left hand side we see that there are two variables being separated by a comma. We can understand that therefore this function is going to return two values. That is why we are having two value variables on the left hand side. And when we look at this function, we see the return part, we see yes, there are two values that are being returned by this function. The max value, which is the first return, is going to be assigned to the first variable from left. Then we are having the mean value, which is the second return parameter. It is going to be assigned to the second variable, which is mean val. Okay, so this function, whenever it's called, we are passing one argument, and we understand that even before reading the function, we understand that this function is going to return two values and assign them to these two variables, max val and mean val. When this function is called, we are having the execution of this part. We're going to use the max and min function. So this is the function that we're going to use, max and min. Okay. So this function max is a built-in function in Python that can help us to find the maximum value. But we want to find the maximum value in my set, yes? So we are going to put the name of my set in parentheses. So we are going to also find the minimum value of my set. So we are going to put the name there. So when the maximum value of the my set is found, it is assigned to max value. And when minimum value of my set is found, it is assigned to min value. And in the end, we are returning both values, max value and min value. Okay, and these are assigned to max val and min val, because here on the right hand side we are having the call of the function. And finally, we are showing these in the output. So max val and min val, both of them are being printed out in the output. And even if I change the numbers, so you see that if I change, for example, 19 to 80, now 80 is the largest number in this set. So when I run the code one more time, we see that maximum value is 80. Okay, it's not 47 anymore. And if I change 25 to 1, we see that the mean value is 1 now. So everything is updated. So this is the way to find the maximum value and minimum value in a set. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to find repeated items in a tuple. In order to find a repeated items in a tuple, we can define a function in Python to do the work for us. But here we see that this is my tuple. Okay, we see my tuple is there, it's defined there. Then we call this find repeated items function. But let me show you the tuple first. So you see this is a tuple. It has a few elements. So 1, 2, 3, 4, 2, 5, 3, 6, 7, 2. After looking at the tuple carefully, we see that there are two numbers that are being repeated there. So we are having number 2 being repeated and number 3. So these are two repeated items in my tuple. So you see 1, 2, 3, 4. Up until here, there is no repetition. So here we are having the first repetition of 2, then we are having 5. It's okay. 3 again, it is repeating. 6 and 7 are unique, and then again 2. So we are having number 2 and 3 being repeated in my tuple. So I would like to write a function in Python to give me these two repeated items. Okay, so, and this is my tuple. Now, in order to do that, I call a function which is named find repeated items, and I'm having one argument. So there is only one argument when we call the find repeated items function. And this argument is my tuple. So this is the function. Whenever this function is called, we should see the execution of this part. So this is the tuple name in the function. We call it top, but in out of the function, we call it my tuple. So just keep that in mind that top is the same tuple that we are having it here. Okay. So here we are creating a set in order to make sure that the repeated elements are assigned to it. Okay, so we are creating a set here called repeated items, and we are creating a set to check elements that have been seen. Okay, so these are the two sets, seen and repeated items, that we are creating here. Then we are iterating over all of the items in the top. So meaning that we are going to have in the first iteration item equals 1, second iteration item is equal 2, third iteration items equal 3, fourth iteration items equal 4, fifth iteration items equal 2, etc. until the end. Okay, so this is my for loop. Here we see that we check if that item is in the scene set. Okay, we are going to track the elements that have been repeated in the scene set. So we check to see if that item is in that set. If that item is in that set, we are going to say add that item to the repeated items set. Okay, so let me illustrate it with a numerical example so it would be easier. First iteration, item equals 1. Okay, so we check if 1 is item in the first is in scene set. Is it there? No, because this set is empty now. Okay, so this set is now empty, so it's not there. So because it's not there, we are adding this item, which is equal to 1. That item is being added to the repeated items set. Okay, to the repeated item set. So now we can have the repeated items set equals, now it has the value 1 because we just added it. Let me say it one more time. In the first iteration, item equals 1, which is the first element of the tuple, because we are iterating through the tuple, each element one by one. We check if that item is in scene. Is it in the scene set? No, scene set is empty. Now it has no values. So scene set, it's having no values for the moment. It is empty now. Okay. So is it there? No, it's not there. So sorry, I made a mistake here. So if it's not there, okay, this statement is false because that item equals to 1 is not in the scene. Okay. So now that it's not in the scene, here this statement is false. Therefore, this part is not executed. We are going to the else part. We are going to add that item in the scene set. Okay, so number 1 is being here. So let me say it one more time because there was a fault there. So in the first iteration, item equals 1, item equals 1 because we're in the first iteration. So we check to see if item is in scene. So scene, we just created it and it's an empty set. So it's not in there. So this statement is not true. Therefore, this part is not executed. We go to the else part and we are going to add that item in the scene set. Okay, in the scene set, it is added. Now scene set has the item 1. Okay. Now we go for the next iteration. So now in the next iteration, items equal 2. Okay, items equal 2. This is the second iteration. We check to see if number 2 is in scene set. So scene set has only one element, which is 1. So is it 2? Is it there? No, it's not there. This statement is not true. We go to the else part. We add the number 2 to the scene set. Okay, so now it's added also. We go for the next iteration. So item equals 3. So 3 is in scene set. Is it true? No, 3 is not there. We are only having 1 and 2. So we go to the else part. We add number 3 to the scene set. So number 3 is also added here. Okay. Then we go for the next iteration. Item equals 4. Items equal 4 equals 4. So we see a 4. Is it in the scene? 1, 2, 3. No, 1, 2, 3 is only there. 4 is not there. So this statement is again false. We go to the else part. We add number 4 to the scene set. So number 4 is being printed here. Okay, is being inserted here. Then in the next iteration, item equals 2 again. You see, after 4, we are having number 2. So number 2 is there. Now that number 2 is there, we check to see if number 2 is in scene. When we check the scene set, we see yes, number 2 is there. So this statement is true now. Now that it's true, we are going to execute this part, meaning that we're going to add number 2 to the repeated items. Okay, so the repeated items. This is the set, which was empty so far. So now number 2 is being added there. And we go for the next iteration. Now item equals 5. So 5, is it in the scene? 5, we don't have it. So we're going to add it to the scene. So 5 is added here. Next iteration, the value is 3. So item equals 3. We check item if 3 is in the scene set. Yes, 3 is there. So now that the 3 is there, add that item to the repeated items also, meaning that this item was already inserted this in the scene set. Okay, so it's a repeated item. This is why we are adding it in the repeated items set. Okay, so 2 and 3. After that, we are having 6 and 7. Okay, after that, we are having 6 and 7. So 6 and 7 are not already there in this scene set. So scene set is now 6 and 7. Then we are having the item equals 2. So 2 item 2, is it in the scene? Yes. Therefore, you need to add it, number 2, and add number 2 to the repeated items. So repeated items is having 2 and 3, but because it's a set, we cannot insert another number 2 there, because one of the features of the sets was that we cannot insert repeated items. Okay, so 2 and 3, we know that it is already being repeated in the original tuple. We don't have to insert it anymore. Therefore, it's not going to be inserted. Why? Because 2 is already there, and one of the features of the set is that they do not allow us to have duplicates. Now, the repeated items set and the scene set, both of them are completed. And now we are here returning the repeated items, which contains 2 and 3. Now, this is the call of the function. So the output was the repeated items set, and that set is assigned to result. And when we run the code, we are printing the result, which is 2 and 3 in the output. So in this coding exercise, we learned how to find repeated items in a set. First of all, we were having the original tuple, and we were having 2 sets. We wanted to keep the unique elements of the tuple in the scene set, and we wanted to have the repeated items of the tuple in the repeated items set. Okay, and we wrote a for loop, and we were iterating over all the elements of the original tuple, and we were checking to see if that item is already in the scene set or not. If it's not there already, we are going to insert it. But if that item was already in the scene set, we realized that it's a repeated item, so we were inserting it in the repeated items set. Thank you for watching.